This spring, or last year actually, a year ago, my brother and his family moved in, and then in March they left, and they left a bag of carrots. See, last summer, I saw a bunch of carrots, carrots that had gone to seed in my garden, and I was like, oh, I don't need these. I have lots of carrot seeds downstairs, so I pulled them out. But when I went looking for carrot seeds this spring, guess what I didn't have? But anyway, when my brother and his family left, they left behind a bag of store carrots, which, whatever. We'll deal with it. But we don't eat them so much, so I planted them along this edge, and I'm letting them go to seed. This is a carrot seed head, blossom head. You can see the different stages. Okay. This one is completely closed. But what you're looking for is pollen. And that is what insects look for. These are primarily insect pollinated. But when I look at these, if you look, you should be able to see the anthers and the pollen sticking up from the flowers. And I see none of that. When I shake these heads, no pollen falls off. And this is probably, and I'm going to let them continue to grow, but this is probably cytoplasmic male sterility. If we get any carrot seeds, I will keep them, but I'm going to keep them separate. I'm horrible at keeping seeds, or keeping carrots, growing carrots. But male sterility means that there are a bunch of different ways that it manifests. Mostly lack of pollen. Some of them, the male flowers actually deteriorate. It just depends on which type of plant you're working with. Now, many of the domestic cultivars, that way, have been bred for male sterility. Because that makes it much easier for a breeder to control what they get. So, carrots, potatoes, tomatoes in some cases have all been bred for male sterility. So you get an all-female plant is essentially what you get. You get a plant that has no male parts on it, no male flowers, no pollen, all these kind of things. It depends, like I said, it depends how it manifests, depends on the plant and the genetics. So, if these are male sterile, I'm not going to get any seeds. Now, there is a chance that one of them has a partial or incomplete male sterility gene, and we'll get one male plant which will then pollinate all of the female plants. But these seeds have got to stay separate, because I do not want this. If I grow carrots, if I can figure out how to get them to grow here, I cannot have the male sterility gene in my carrots. So, I suspect that this whole row is male sterile, but we shall see. I will talk with you later.